Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a theoretical physicist and as a mechanical and systems engineer. Today's screencast, like most of my weekly screencasts, will be on the reciprocal system and how it compares to conventional theory. One of the main elements of the reciprocal system of theory is that subatoms and atoms are rotating photons. This is very, very different from standard theory, where subatoms are comprised of quarks and subatoms comprise an atom. The reciprocal system totally disagrees with that. Subatoms are single rotating photons. Atoms are dual rotating photons. Now, what's interesting is that it's been found that photons may combine and create mass. This is a very interesting article from Science Daily, February 15, 2018, from MIT. It says here, try a quick experiment. Take two flashlights into a dark room and shine them so that their light beams cross. Notice anything in particular? The rather anticlimactic answer is, of course, probably not. That's because the individual photons that make up light do not interact. Instead, they simply pass through each other like indifferent spirits in the night. But what if light particles could be made to interact, attracting and repelling each other like atoms in ordinary matter? Well, they wouldn't really attract and repel. But anyway, one tantalizing, albeit sci-fi possibility, lightsabers, beams of light that can pull and push on each other, making for dazzling epic confrontations. Well, that's science fiction. But at MIT and Harvard here, photons can be made to interact. And let's see, this comes from the journal Science. Let's see. Lester Wolf, professor of physics at MIT, Professor Mikhail Lukin from Harvard University, observed groups of three photons interacting and in fact sticking together, forming a completely new kind of photonic matter. Well, two photons can basically stick together, but three would be unstable because there'd be interference in the rotations. But anyway, this is interesting. In controlled experiments, the researchers found that when they shone a very weak laser beam through a dense cloud of ultra-cold rubidium atoms, rather than exiting the cloud as single randomly spaced photons, photons bound together in pairs or triplets, suggesting some kind of interaction, in this case attraction taking place among them. Well, photons normally have no mass and travel 300,000 kilometers per second, the speed of light. The researchers found that the bound photons actually acquire a fraction of an electron's mass. These newly weighed down light particles are also relatively sluggish, traveling about 100,000 times slower than normal non-interacting photons. It's not that photons can attract, and I mean they can entangle, but they don't really attract or repel one another per se. But they can combine. That's the whole point of how atoms rotate and create mass. So what's interesting here, well, let's see, let's scroll down. The researchers, according to this article, then developed a hypothesis to explain what might have caused photons to interact in the first place. Their model, based on physical principles, puts forth the following scenario. A single photon moves through the cloud of rubidium atoms, briefly lands on a nearby atom before skipping to another atom, like a bee flitting between flowers until it reaches the other end. Another photon is simultaneously traveling through the cloud. It can also spend some time in the rubidium atom, forming a polariton, a hybrid that is part photon, part atom. Well, that's kind of funny. Then two polaritons can interact with each other via their atomic component. Oh, I see. It's because the atoms are repelling and attracting one another. Okay, that's fine. That's legitimate. Well, anyway, the basic point, though, is that photons can combine. And in the reciprocal, they're orthogonally related in an atom. All right. So for decades now, the reciprocal system has shown that subatoms and atoms are rotating photons. The experiment discussed in the above link shows indeed that photons can combine to create mass. Of course, we need much more information to determine exactly what kind of subatom has been created here. It's probably an unstable subatom. I'm almost sure of it. There are only certain kinds of subatoms and atoms which are stable. Hence, we get the list of subatoms and atoms that we currently have. Okay, so that does it for today. Photons can combine, just remember that. With the simplest possible explanation of the reciprocal system, please obtain my work, The Unmysterious Universe, available from Amazon.com or transpowercorp.com. All the concepts are here, many diagrams. It's the easiest way to learn the theory. Now, if you do want all the mathematics, I mean all of it, please obtain my magnum opus, Existence and Interactions, a computational treatise of the reciprocal system, the true theory of everything. 711 pages in the PDFs file, 711 slides in the PowerPoint file. Keep you busy for months. There are thousands and thousands of equations, diagrams, tables, figures, everything. Okay, then, once you're through with that, you can consider getting my 2 database modules, which make it easy to apply the theory to your scientific or engineering practice. The Reciprocal System Microcosmos Database and the Reciprocal System Macrocosmos Database. The Microcosmos Database has the calculation for all the properties of matter, including photons, subatoms, atoms, compounds, alloys, both material and cosmic particles. There's an excellent graphing routine included in the program. The Reciprocal System Macrocosmos Database has all the properties for the astrophysical realm, macrocosmos, including the universe as a whole, galaxy clusters and groups, stellar clusters, stars, planets, moons, minor bodies like asteroids and comets, nebulae and dust clouds and voids. Very comprehensive. This module also has a great graphing package. So, makes it very easy to apply the reciprocal system. Tens and tens of thousands of calculations are involved in both database modules. It represents a vast amount of work. Basically has all the work I've done in the past 50 years on the reciprocal system. These 2 database modules are the verification of the theory. So yes, the reciprocal system is scientifically verified, although it will take my opponents in theoretical physics probably many, many decades to see the light. All right, well, thanks for your attention. And again, please study the reciprocal system and prove it for yourself.